Okay, to demonstrate impulse, I have two carts here in the center of the track. So they are exactly in the center, so they are exactly equidistant from the ends of the track here. And they're identical carts, so they have the same mass. And the plungers are compressed and facing toward each other. So when I press this button, one of the plungers is going to decompress. And it's going to apply a certain amount of force on the other cart. Let's say I depress the plunger from the blue car comes out. It pushes on the red car. The red car is going to push back on the blue car. We know from Newton's third law they apply the same size force to each other. Now we can also kind of figure they're going to apply that force for the same amount of time, right? If the blue car pushes the red car for, say, 0.1 seconds, the red car is going to push the blue car for, say, that same time, 0.1 seconds. So therefore, the impulse on both cars will be the same, because impulse is net force times time. And that impulse causes a change in momentum, which is mass times change in velocity. Since they have the same masses, they should have the same velocities. And if they're equidistant from the two bricks, they should hit the bricks at the same time. So you're going to kind of listen for that, see if you can hear them hit at the same time or different times. So here goes. Sounded like the same to me. Okay, now I am going to make one of the carts twice as massive by adding one of these bars. All right, which means that if impulse causes a change in momentum, and if both cars can have the same momentums, or I should say momenta, this car, which has twice the mass, will travel half the distance after I depress the plunger. So let's see. This one's going to travel 20. This one's going to travel, alright, so I got to go here. Let's make that 44 and 22. Okay, so I have it set up so the blue car is 22 centimeters away from this brick. The red car is 44 centimeters. So if the red car is going to cover twice the distance in the same time, it has twice the velocity, but the blue car has twice the mass. So if they hit at the same time, they will have the same momenta. How about that? Same time. Okay, should we go for 3? Now I've tripled the mass of the blue car, which means it's going to travel 1/3 the distance of the red car. Because if the red car has 1/3 the mass of the blue car, it'll travel 3 times as fast, and then they'll have the same momentum. So let's see. Okay, so this is at 15, 17, nope, that's too much, 16, yeah, alright. This is about right. So this edge of the blue car is 16.5 centimeters from this brick. 16.5 times 3 is 49.5, and this red car is 49.5 centimeters from the end. All right, so 3 times the distance, 3 times the mass equals the same momentums. Here we go. Oh. What do you know? Seems to me like they hit at the same time. So in all 3 cases, the plunger applied an impulse to the red car, which caused a change in momentum. The red car applied the same impulse to the blue car, which caused the same change in momentum.